You know when you picture a really iconic bridge, what's the first thing that pops into your head? For, gosh, almost 100 years, it was probably the Golden Gate Bridge, right? Those massive orange-red cables, a total symbol of American engineering power. But today, a whole new generation of giants is rising up, and they're completely rewriting the rules of what's even possible. So in this explainer, we're going to dive deep into how China became the world's new infrastructure colossus. And we're going to use their absolutely mind-blowing, record-breaking bridges to see how they did it.
Okay, let's just start with this comparison because it says so much. Over on the left, you've got the Golden Gate, an absolute miracle when it was finished back in 1937. It was a monument to an era, a time when people really believed that nothing was impossible. And on the right, the Huajiang Canyon Bridge, set to open in 2025. It's going to be the highest bridge on the planet, and get this, it was built start to finish in about 3 years. This isn't just about two bridges, you see. It's a snapshot of this huge global shift in who's leading the world of engineering.
And that contrast right there, it brings us to the big question, the one we're going to try to answer today. How? How did the epicenter of these incredible engineering miracles make such a massive, dramatic shift to the east? What's going on behind the scenes, the tech, the systems, the sheer ambition that's fueling all of this?
So to figure that out, here's the plan for our journey today. First, we'll look at what's being called a new golden age. Then, we're going to break down how they're literally building across the clouds. After that, we'll dissect the secret recipe for something called China speed. Then we'll see the real-world economic impact of these projects. And finally, we'll look at how the rest of the world is reacting to all this.
All right, first up, this new golden age. You know, China's just relentless drive to build the impossible. I mean, we're talking everything from high-speed rail that crisscrosses the country to these colossal dams. It's actually earned them the nickname infrastructure maniac. But this isn't just about building for the sake of it. It's a core national strategy that's using infrastructure as the main engine for both economic growth and connecting to the rest of the world.
So let's zoom in on our main example, our case study, the Huajiang Canyon Bridge. We are going to deconstruct how this thing was actually built, because trust me, this is not just another bridge. It's a statement. It's like the pinnacle of engineering, showcasing this incredible ability to conquer some of the most extreme, challenging geography on the planet.
And to really get a feel for the scale we're talking about, just look at that number, 625 meters. That is over 2,000 feet straight down. To put that in perspective, you could stack 2 Eiffel Towers on top of each other in the canyon below and they still wouldn't touch the bridge deck. It's just staggering. And with that, it officially takes the crown from the Beipanjiang Bridge as the new world record holder.
So the big question is, how on earth do you build something this massive in a place that experts once called almost impossible for modern construction? Well, you do it in 4 absolutely incredible stages. First, you've got the foundations. In this crazy, rugged terrain, engineers had to drive these massive concrete piles 68 meters deep into solid bedrock. That's like burying a 20-story building underground just to get a solid anchor. Then, the towers. They used this amazing hydraulic climbing system so the towers literally grew upwards at almost a meter every single day. Third, the cables. Now, to get the first line across that 1,400-meter wide canyon, they didn't use helicopters. They used a drone. A drone! To fly a single, thin pilot rope across, which they then used to pull bigger and bigger cables. And finally, the deck itself. 93 individual segments, each one weighing 200 tons, were hoisted up and locked into place with millimeter precision, all while battling these insane high-altitude winds.
But the real innovation here, it's not just the construction. The Huajiang Bridge is more than just steel and concrete. It's a living, breathing, smart megastructure. It's wired up with over 400 high-precision sensors that are constantly checking things like temperature, wind speed, stress, and vibration. All of that data feeds into what's called a digital twin, basically a perfect virtual copy of the bridge. This lets engineers see into the future, predict problems, schedule maintenance, and even actively fight back against extreme weather, making sure this incredible bridge stays safe and stable for a very, very long time.
Okay, so pulling off a project like that in just 3 years is it's mind-boggling. But here's the thing, it's not a one-off fluke. It's the result of a repeatable system. So now, let's take a look at the China speed formula, the actual system behind all this spectacle.
To really understand China speed, just look at the Sanyuan Bridge in Beijing. This thing is a major artery with over 200,000 cars a day. When it had to be replaced, a normal project would have paralyzed that part of the city for months. Chinese engineers did the whole thing in 43 hours. It's incredible. They built the new 1,300-ton bridge section nearby, cut up the old one, and then used these giant modular transporters to just roll the new one right into place. Unbelievable.
And if you think 43 hours for a bridge is insane, this next one is it's almost hard to believe. In the city of Longyan, engineers built an entire high-speed railway station, we're talking tracks, platforms, the whole shebang, in 9 hours. 9. The secret? Just like giant Lego blocks, they pre-built everything somewhere else, then thousands of workers just swarmed the site in this perfectly choreographed dance to snap it all together.
This incredible speed isn't some kind of magic trick. It's the result of a very specific recipe. First, you have centralized leadership, which means decisions get made and acted on fast, without years of debate. Second, these huge state-owned construction companies all work together seamlessly. Third, China makes its own steel and cement on a mind-boggling scale, so there are never supply chain holdups. Fourth, like we just saw, prefabrication is king. Fifth, they have a massive, highly skilled workforce that can keep sites running 24/7. And finally, they use standardized, repeatable designs, which shaves years off the planning process.
Let's just pause on that point about materials for a second. The statistic you're seeing here, it is just astonishing. In just 2 years, 2018 and 2019, China produced and used more cement than the United States did in the entire 20th century. Just let that sink in. That single fact is the bedrock, quite literally, of this whole infrastructure boom. You can't build this fast if you can't make the stuff to build with, and nobody on Earth does it on this kind of scale.
This quote from a British academic just nails it perfectly. The concept is called parallel engineering. It means that while one team is tearing down an old bridge, another team is already building the new one in a factory somewhere, and a third team is still finalizing the design details. All three things are happening at the same time, not one after the other. They are literally compressing time down to its absolute physical limits.
So, we've seen the how, but what about the why? Why build all of this? Let's move on to our next section, from mountains to markets. This is where we see why these incredible feats of engineering really, truly matter.
This slide really brings home the human impact. Before this bridge, just to get across the gorge, you were looking at a winding 70-minute drive that basically cut these towns off from the world. After the bridge opens, that same trip will take 90 seconds. Think about that. One single piece of infrastructure connects these once remote communities directly to the National Expressway network and, through that, to the economic juggernaut that is the Pearl River Delta. It's a total game changer.
And that shows you that these projects are about so much more than just concrete and steel. They don't just make it easier to move goods around, they create entirely new economies out of thin air. The Huajiang Bridge itself is being designed as a tourist hotspot, with glass skywalks, one of the world's highest bungee jumps, and even paragliding launch pads. They are literally turning a piece of critical infrastructure into an adventure destination. And to really capture this whole transformative vision, the service area for the bridge has been given this beautiful name, Yundu. It translates to crossing the clouds via one bridge. It sounds poetic, but it's also literal. It captures the whole idea that these mountains aren't barriers anymore. It's about connecting these isolated communities not just to the other side of a canyon, but to their own future.
Okay, for our last section, let's zoom all the way out to the global picture. Because as you can imagine, the world is absolutely taking notice of these achievements. And what we're witnessing is a fundamental paradigm shift in the world of engineering.
The numbers here are just, well, they're stark. Of the 10 highest bridges on planet Earth, 8 of them are in China. And get this, half of those are in Guizhou province alone, the same rugged, mountainous region where the Huajiang Bridge is. This isn't some gradual change, it is complete and total dominance in modern, high-altitude bridge building.
There's this saying that goes around in the global engineering community, and it just perfectly frames the history here. It says that leadership in this field passed from the West to Japan in the 90s and has now landed firmly in China for the 21st century. Chinese bridges have become a kind of global calling card for the nation's incredible strength.
And hey, don't just take my word for it. This isn't just an internal observation. Listen to this comment from John Davis, the president of the American Society of Civil Engineers. He was talking about the Beipanjiang Bridge, the former world's highest, and he estimated it would be a 20-year project in the US. Chinese engineers did it in 6. That kind of expert opinion really drives home how huge the gap in speed and execution has become.
Maybe this comment from the New York Times sums it all up best. They said China is applying Tesla-style innovation to infrastructure. And that's so powerful because it suggests this isn't just about building faster or bigger. It's about fundamentally rethinking the entire process, blending technology, speed, and massive scale in a way that is totally disrupting the global status quo.
So we end right back where we started.
The golden age of the Golden Gate has given way to this new, cloud-crossing era of the Hujiang Canyon Bridge. A new bar has been set, not just for what's possible in engineering, but for the incredible speed at which it can be done. And that leaves all of us with a really fascinating question. As this new era of engineering dawns, what will the world build tomorrow?